Welcome back. In this unit, we're going to create a function that allows us to return the repayment amount for a loan. And in the process, we're going to introduce you to the struct variable type. As you can see, our tests are failing on the right. In order to pass our tests this time, we need to create two different items. The first is we'd like a state variable that contains information about the current open loan. And the second is that we would like to have a function that returns the repayment amount that we'll need to do to pay off this open loan. In order to do so, we're going to store all the relevant information about the open loan within a single variable. Fortunately, we have the struct, short for structure, which is a custom data type that can group multiple different variables into one sort of rich object. It sort of functions like a Pythonic object in that it can contain multiple properties within it. And this can be nearly any Vyper data type. So you can have, per this example, integers and decimals mixed into it. You could mix in strings. You could include arrays. The only thing that you really can't do is mappings, which is fine because we're not covering mappings until the next unit anyway. But you can have your structure contain other structures, and allowing you to contain and build these kind of rich nested objects. So there's a lot you can do with structures. There's an analogy and solidity to this. So it's a pretty commonly well-known property of smart contracts. Let's go ahead and use some structures to create this new open loan type. And you might notice that in this file, mentor.vy, we've added a little bit of documentation to make it look a little prettier. If you're still working off your old copy, then the line numbers might be different. We just recommend you start from the current unsolved version. Let's add a structure. And we're going to call this a loan. And this is going to contain everything we need to calculate the repayment amount. So you could just calculate the repayment amount directly. Or in this case, we're going to add some specific properties for the loan. So one thing we might need to know for the loan is the liquidation price for this particular loan. This would be a uint 256. We'd also want to know how many coins did they deposit. This would also be a uint 256. And all we really need to do is multiply these together and divide by 10 to the 18th. So we're not going to add an extra storage slot to store the combination of these two together, but you can see where this is pretty useful. Now that we've defined the struct of a loan, we could use this directly. So let's go ahead and add in a concept of an open loan, which will just reference this loan directly. At the end of the tutorial, we'll show you how this gets output when you call it directly. But this is going to return a loan structure. So internally, we can access both the liquidation price and the deposit amount. So let's scroll down a little further. And let's add a new internal function because we're going to need to reference this multiple times. And we'll call it repay amount. This is going to return a uint 256. And in the moment, we are not storing multiple different loans. So this contract's at the moment only capable of storing information on one loan. So we're not going to pass any like loan ID to it or anything. It's just going to be a vanilla function that's going to take the loan, reading it from this state variable open loan that we created. And it's going to return the loan liquidation price times the loan deposit amount divided by 10 to the 18th. Note that we can access the structure properties not by numerical offset, not by square brackets or anything, just like you would do it with a Pythonic object, loan.attribute type, which in this case is liquidation price and deposit amount. So in order to pass the tests, we need to create a view function that's simply going to parrot this internal function. Again, until we discover mappings, we're not going to be able to do any loan ID or anything, so it'll just be a fixed repay amount. So let's add some documentation. Amount and return amount of tokens required to repay. And this will call the internal repay amount function. And finally, whenever we are creating a new loan in this state modifying mint function, we're going to have to set the liquidation parameters. So you probably, if you caught it on here, in order to set the or declare a structure variable, it's going to utilize the structure, round brackets, and then all the properties in curly brackets inside with no quotation marks around it. So for our case, this is going to look like, first we'll create a liquidation price. We'll get the current price in dollars. We'll multiply by our collateral percentage, in this case 80%, because we hard-coded that. And then we will assign to the open loan, which is a loan. So loan, round brackets, and then within curly brackets and no quotation marks, we'll pass the liquidation price as the variable we just created. And the deposit amount will be the raw quantity deposited here. We'll save this and we'll run our tests over here. As promised, I will also show you what this looks like on the other side. So if we do test withdraw, when Brownie is retrieving this open loan, which is simply the raw structure, it's going to get these two properties and return these as a tuple. So when you pull in the open loan, you can grab the 0th element, and that's the first property in the structure, liquidation price, and the first element of it is the deposit amount, the second element in the structure. Pretty simple. Very useful concept, though. You see structures emerging all the time. It's a very helpful way to kind of bundle and store data together. If you have any questions about this, please drop these in the comments. You can see the tests pass, so everything's looking great on our side. But most important is that you're following, so any questions you have, we'll be happy to answer.